So now, last video we took this part of the circuit right there and gave it to the input of an op amp. Instead we got a couple NPN bipolar junction transistors in this particular circuit right there, wired as a Darlington pair. So I will put this a little closer. This is going to respond to light, and this is not, you know, a circuit you would probably ever build to actually do something productive. Instead, it's more just kind of a demonstration circuit. So there you can see I was able to use the flashlight, kind of like when it comes to the LEDs right there, they're kind of like little solar cells, little solar panels right there. And for some reason the LED is not getting as bright as it was earlier, and it is getting dim faster, so we're not getting as much. But in any case, that doesn't really matter. The main takeaway is we are giving a weak signal, a little bit of current, more current than what the op amp needed. Op amp didn't let basically any current go through at all. We're going to get a little bit there, so that'd be tricky to measure the exact amount. But the main takeaway is that this is a voltage follower. We got a Darlington pair though, so you get more than 0.6 volts difference there. A little bit of current is going to start flowing. That's going to allow many times the current to flow through that direction as well. It's going to pass whatever current is needed to maintain that voltage, even though current is flowing. Because remember, when current starts flowing, voltage goes down, so we just get a trickle of current. That allows a lot more current to flow that way to maintain the voltage without stealing too much current from the source. But again, this current is very, very weak. We need a little bit more. So we got another about 0.6 volts, especially at these very low voltages, maybe even down to 0.5 volts. I don't know. But low currents, I mean. But in any case, we have another about 0.6 volts. So we're probably losing about 1.2, maybe 1 volt in this process going down. But again, we got that very, very small trickle of current there, allowing much more current to flow. But still, that's low. So we got another transistor to amplify it even more right there. That's the purpose of the Darlington pair. So you lose more of the voltage if you wire it as a voltage follower right there. But the very small amounts of current you are working with get amplified. If this was a gain of 100 and that was a gain of 100, then you would have a gain of 10,000. 100 times 100. The gain goes way up. That's the main thing. But you do have a little more voltage loss. Something you got to keep in mind. So, in any case, we should get across the LED about the voltage that we have over there minus about 1 volt. So, when we had the op amp, we saw we could get about 3.7 volts across this particular capacitor there, charge the capacitor. We actually need to charge the capacitor in this one to get the voltage up. Let's try this without the capacitor. See if, obviously it won't store a charge, and there we go. Pliers would have worked better, but didn't think to do that. So, there you can see. Now it lights up pretty much instantly. Hopefully you can see that. I'll try to get the wash from not showing. But yeah, there you can see the LED is lighting up pretty quick right there. Turns off right away though when we remove the light, obviously because we don't have this capacitor right there. So again, this is just this is not a practical circuit for probably anything. You might go your entire life, even if you built a lot of circuits, without building something like this. You probably find a good use for Darlington pair transistors, but not so much for shining lights on LEDs. The bigger benefit for doing something like this, and by the way, I'm working with 5 volts. I got a 220 ohm resistor protecting the red LED. But the main takeaway is, especially if you got LEDs for some reason, you got LEDs in the circuit and they come to the input of an amplifier. If you hit light on them, you might get unexpected results. So that's just something to be aware of. If you have LEDs, and yeah, for some reason they come to an input, then even the light level, just the lamp above us right there, might do something if it's a sensitive enough circuit. This one's not terribly sensitive. So, gonna leave it there. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.